Alright, so now we're going to be looking at solving compound inequalities. A digital music service offers two different plans. The first has a $9 membership fee and charges $1 per download. The second has a $25 membership fee and charges 50 cents per download. So how many songs must you download for the second plan to cost less than the first plan? So first we need to take these words and kind of put them into an algebraic expression. So let's talk about the plans individually. So let's look at plan number one. Plan number one has a $9 membership fee and $1 per download, which means if I download nothing but I sign up, I still have to pay $9. And then for every song I download, it's $1. So this is not going to change, which means there's no variables attached. So it's just a plain $9 plus $1 per download. So I'm going to go ahead and call D downloads. So every download's $1, so 1D. All right, now plan number two, regardless of my downloads, I have to pay $25, and then I have 50 cents per download, so 0.50 per download. Now I want to know how many songs must I download for the second plan to be less than the first. So I'm not looking at what makes them equal, but what makes it less. So I want to see if this is going to give me my money's worth if I download a lot. So let's go ahead and do plan 2 has to be less than plan 1. So let's substitute that in. And let's go ahead and isolate D. So I get 16 is less than 0.5D. Dividing your side by 0.5. Dividing by 0.5 is the same as dividing by a half, which is the same as multiplying by 2. So that's 32 is less than D, which means D has to be greater than 32. So I must download more than 32 songs, which means I actually have to download 33 in order to get my money's worth. Now you can join two different inequalities with the word and or to have a compound inequality. Now to solve a compound inequality containing and, we have to find all the values of our variable that make both inequalities true. So that's the biggest thing here is both inequalities must be true in those specific values of that variable. So now I'm going to solve this compound inequality. It is an and compound inequality. So I'm actually just going to solve these separately but keep the and in between them. And I like to write it with the X on the left-hand side. Bring down that and. Alright, so X has to be bigger than 3 and X has to be less than or equal to 6. So let's look at what that looks like whenever I graph it. So if I have 0 over here, 1, 2, 3, 4, 5, 6. So I want to be bigger than 3. But I want to be less than or equal to 6. Okay, so where do they share common overlap? Well, that's going to be right here, right? Well, at 3, I have to have an open circle, and at 6, I must have a closed circle, and then I'm going to shade between them. So this right here would be my final answer. For and inequalities, you can actually rewrite them as one inequality statement and not have the word and in between them. So in order to do this, you must have both of them isolated with X on one side. So I'm going to go ahead and isolate X. Alright, so I'm going to rewrite this. X is bigger than or equal to 8/3 and X is less than 4. So if I wanted to actually graph this, First, I would want to recognize my key numbers here, which are 8/3, which is between 2 and 3. It's about 2.6 repeating, and 4. So I'm going to make sure that I mark where my 0 is. 1, 2, 3, and 4. Now I want to be greater than or equal to 8/3, so that's right around here. And I want to be greater than, so I'm going to go to the right. And I want to be less than 4, but not equal to. And since it's and, I want all the values that are actually in common. So that's going to be all of these values here. So, since I'm between those values, x lives between the values. So I can actually write x is between 4 and 8/3. So I can rewrite it with one inequality and be between those two values. Notice how the inequalities are facing the same direction. They must always face the same direction whenever you are writing a and compound inequality into one inequality. You cannot do this, however, with or compound inequalities. Alright, so now let's look at or compound inequalities. So these are the values of variable that make each of the inequalities true. It does not have to be both, okay? It's not just both, it's each individually. So normally, they do not face the same direction. They're going to be pointing in different directions, whereas the and inequalities come together and it's the overlapped region. We are now going to be looking at the opposite sides of the number line. Of course, just like anything in mathematics, there will be exceptions to this, but in general, or inequalities will go in opposite directions and inequalities will come together. Alright, so now let's find the solution to this or compound inequality. So we're going to solve each inequality separately, but we must keep that or in between them. Make sure you bring down that or. It's very important that you do not forget that. Alright, so our key numbers here are -1 and -5. So let's go ahead and plot those on our number line. So I am going to have a closed circle on -1 because the equal to sign there. And because the k is on the left-hand side, I can go ahead and assume that I shade in the direction that the inequality is. So I'm going to shade to the right. And then my other key number is -5. It looks like I'm going to have an open circle at -5. And because the k is on the left again, I just follow the inequality symbol, so I'm going to shade to the left. And there's my solution, and there's the graph of the solution. Therefore, any of the values over here, not including -5, so to the left of -5 on the number line, and any values to the right of -1, including -1, will make the original compound inequality a true statement. Go ahead and try these problems in your notes.